the universe is far from static. Over billions of years, galaxies drift, interact, and sometimes collide in spectacular cosmic mergers. One of the most dramatic future events in our galaxy's story is the impending collision between the Milky Way and its closest large neighbor, Andromeda, M31. While this merger will profoundly reshape our cosmic home, the fate of the two galaxies' supermassive black holes, SMBHs, remains one of the most fascinating aspects of this process. Current observations indicate that Andromeda is hurtling toward the Milky Way at a speed of about 110 kilometers per second, 68 miles per second. At this rate, astronomers predict that the galaxies will begin their initial interaction in about 4 billion years, leading to a full merger within 5 to 6 billion years. The entire process will span several billion years, unfolding in several key phases. 1. First close encounter, 4 to 5 billion years. Andromeda and the Milky Way will pass through each other, distorting their shapes due to mutual gravitational forces. Tidal interactions will trigger immense bursts of star formation. 2. Repeated passages, 5 to 6 billion years. The two galaxies will oscillate around one another as gravity pulls them back together. Their spiral structures will become increasingly warped and stretched. 3. Final coalescence, 6 to 7 billion years. The cores of the two galaxies will merge, forming a single elliptical galaxy often referred to as Milky-Way. 4. Black hole merger, about 1 billion years after galaxy merger. The supermassive black holes at the centers of each galaxy, Sagittarius, a star in the Milky Way, and M31 star in Andromeda, will gradually spiral toward each other, eventually merging in a spectacular cosmic event. When two galaxies collide, their central black holes do not immediately merge. Instead, a complex sequence of events unfolds. 1. Dynamical friction. As the galaxies merge, their SMBHs, initially separated by thousands of light years, sink toward the new galactic center due to interactions with surrounding stars and gas. This process takes hundreds of millions of years. 2. Binary black hole formation. Once the black holes get close enough, a few light years apart, they form a binary system, orbiting each other while continuing to lose energy through gravitational interactions. 3. Gravitational wave emission. As the binary black holes spiral inward, they emit powerful gravitational waves, ripples in space-time predicted by Einstein's general relativity. These waves gradually sap the system of energy, shrinking the orbit. 4. Final in-spiral and collision. Eventually, the black holes reach a critical distance where gravitational wave emission becomes dominant. The in-spiral accelerates until they merge in a titanic collision, releasing enormous energy in the form of gravitational waves and possibly a relativistic jet of energy. The merging of the Milky Way and Andromeda will dramatically reshape the local cosmic landscape, but what will it mean for Earth? New stellar configurations. The night sky will be breathtakingly transformed. Andromeda will gradually dominate the sky, growing larger over millennia before finally blending with the Milky Way. Potential displacement of the Sun. While the vast majority of stars in both galaxies will not collide directly due to the immense distances between them, the Sun and our solar system might be flung into a new region of the galaxy. No direct threat to Earth. While cosmic events will be spectacular, there is no danger of Earth being swallowed by the black holes. The distances involved are vast, and black holes do not suck in objects beyond their event horizons. Detectable gravitational waves. If humanity, or its successors, still exists when the black holes merge, advanced gravitational wave detectors will register one of the most powerful space-time ripples in cosmic history. The process that will lead to the Milky Way-Andromeda merger is not unique. Similar galactic collisions have been a driving force in the evolution of the universe, including the formation of our own Milky Way. Past mergers, the Milky Way has already absorbed smaller galaxies, such as the Sagittarius dwarf galaxy, influencing the formation of its spiral structure. Black hole growth. These mergers contribute to the growth of supermassive black holes. In fact, the presence of such black holes in galaxies suggests that mergers have played a key role in shaping galactic centers. Galaxy morphology changes. Many large elliptical galaxies we observe today are the result of ancient mergers like the one the Milky Way will undergo with Andromeda. While the idea of our galaxy colliding with Andromeda may seem catastrophic, in cosmic terms, it is simply another step in the grand cycle of galactic evolution. The Milky Way, once a young spiral, will eventually merge, morph, and transform into an entirely new entity. Meanwhile, its central black hole, Sagittarius A*, will find itself locked in a dance with Andromeda's SMBH, culminating in an awe-inspiring black hole merger. For now, we are fortunate to witness the lead-up to this grand event from the comfort of our present cosmic vantage point, as we continue to unlock the mysteries of our ever-changing universe.